Welcome to the fascinating world of probability. Have you ever wondered how mathematicians predict the future? It all starts with a fundamental concept called the sample space. In essence, before we can calculate how likely an event is, we must first identify every single thing that could possibly happen. This set of all possible outcomes is what we call the sample space, often denoted by the Greek letter omega or simply S. Let's start with the simplest building blocks, coins and dice. When you flip a fair coin, the sample space is straightforward, heads, tails. But as we add more elements, complexity grows exponentially. If you flip two coins, you don't just have two outcomes, you have four, HH, HT, TH, and TT. According to the law of large numbers, as the number of trials increases, the actual results will converge to the theoretical probabilities defined within these spaces. Visualizing these outcomes can be tricky, which is why we use tree diagrams. Imagine you are picking an outfit. You have 2 types of shirts and 3 types of pants. A tree diagram branches out for each choice, showing us that 2 times 3 equals 6 total combinations. This systematic approach ensures we never miss a single outcome, a crucial step in combinatorial analysis used in fields like computer science and logistics. What happens when we roll 2 dice? This is a classic problem in statistics. Instead of a list, we often use a grid or matrix. By plotting the first die on the x-axis and the second on the y-axis, we create a 6x6 grid representing 36 unique outcomes. Notice how patterns emerge. There is only one way to get a sum of 2, but 6 ways to get a sum of 7. This explains why 7 is the most frequent result in games like craps. In the real world, sample spaces are vital for quality control and science. Imagine a factory testing 3 electronic components. Each can either pass, P, or fail, F. The sample space contains 2 cubed, or 8 outcomes. Scientists use this to calculate the probability of at least one failure. Similarly, in genetics, Punnett squares are actually small sample spaces used to predict the traits of offspring based on parental alleles. As we move into the digital age, sample spaces become massive. Consider a 4-digit PIN code. Since each digit can be 0 through 9, the sample space consists of 10,000 possibilities, 10 to the 4th. This is the foundation of cybersecurity. The larger the sample space of a password, the harder it is for a brute force attack to guess the correct outcome. Understanding the size and structure of these spaces is the first step toward mastering data science and risk management. In summary, the sample space is the map of all possibilities. Whether you are playing a board game, predicting the stock market, or engineering a spacecraft, you must first list your outcomes. By mastering tree diagrams, grids, and fundamental counting principles, you gain the power to quantify uncertainty. References: Johnny Friend, Elementary Business Statistics; J.L. DeVore, Probability and Statistics for Engineering and the Sciences; Sheldon Ross, A First Course in Probability.